Hello and welcome to the Concept 46 video for Algebra 2. This is the very first lesson in our Unit 10 on statistics. In this very first video we are going to be talking primarily about population, samples, and what are statistics. So our goal here is to understand the science of statistics in its different branches, distinguish between population and samples, including parameters versus statistics, and also learn how to interpret a mean and standard deviation for a data set. You will see here, if you look at our vocab word bank here, we have quite a few new definitions, and so we're going to use those definitions to fill in our blanks as we go. So if we look here, the very first blank we're going to use here is going to be statistics. We are going to be talking about that the statistics is the study of the collection, analysis, presentation, and interpretation of numerical data. So whenever we have large groups of numbers together, so it might be, a set of test grades, it might be different GDPs for different countries collected around the world, we need to be able to analyze that data and summarize it, and that is what we do with statistics. In order for us to do that, though, we need to first be able to collect all that data from what we call a population. So a population is a collection of all the elements or individuals, items, or objects. So we can have numerical data for about any group of things, and that's where that population for that group is under that characteristic that is being studied. Now, if we have the entire group, that is the population, but that's usually hard. So what we usually settle for is taking a sample of the population. So a sample is going to be the set of individuals, items, or objects collected or selected from a population by a defined procedure. So, for example, if I have a full group and I take all the different elements of that group to make sure that I can study, then that right there is going to be the population. But, since it's usually hard to get everybody, if I just take a small group of that population, that is going to be our sample. So we need to make sure that we can distinguish between a population and a sample. So let's try this using some local data that we had collected from the past. So it says here in example 1, in Liberty, Missouri, in a 2018 survey of 6,000 households, found that 5,562 have a computer. We need to identify the population, the sample, and then give a description of that sample based on the info found. So remember, population is going to be everybody that would be considered for this study. And so if we're taking and looking at our information there, it is going to be, we're looking at all households in Liberty, Missouri, because we want to be as specific as possible, but it has to be all those households. So this is just going to be all possible households in Liberty, Mo. Now, obviously, it would probably be way too hard or take too long for us to be able to go to every house in order to see if they have a computer or not. So they took a smaller group, those 6,000 households, as the sample. And we want to make sure to describe or summarize what was found, and so that description is going to be that, 5,562 of those households had a computer. Let's go to example 2 here. It says in Clay County, Missouri, a survey of 15,000 individuals under 65 found that 1,290 did not have health insurance. We want to do the same thing here. So if we look here, we see that we do have some numbers here. We have 15,000 individuals, that 65, and that 1,290. Well, those 15,000 individuals were the ones that were being surveyed, so that is going to be actually that smaller group from our sample. So usually it's easier to identify the sample first. But to identify the populations, we need to think, well, what was the group that those individuals were pulled from? In this case, that would be all people in Clay County under the age of 65. And to describe that, well, they found that 1,290 of them did not have health insurance. So now, I want you guys to try this on your own. Go ahead and try the next two for me here. And I want you to identify the population, the sample, and also give a description of that information found. So pause the video and try it now on your own. Okay, so if we go ahead and check your answers against mine for these, in this case, in the first example, it said in Kansas City, Missouri, 2018 survey of 15,000 individuals ages 5 or older found that 1,770 experienced a language other than English spoke at home. So again, that 15,000 individuals are going to be our sample, and those were taken from all Kansas City, Missouri individuals older than 5. And then to describe that, well, that was that 1,770 individuals speak a language other than English at home. You need to make sure to be specific when you're writing out that description, so make sure to include all that. On the second one, it says, to estimate the median household income in Liberty, Missouri, a government agency looked at data from the 4,500 households and found the median income to be $71,686. So again, those 4,500 households that were surveyed would be the sample, and it was taken from the population of households in Liberty, Missouri, and we can describe that as the singular number there of the median income was $71,686. So now that we know about population and samples, let's go further into those descriptions of how to describe that data. And that's where it's going to come to parameters versus a statistic. A parameter is going to be a numerical description of a population. So an example of that would be when we're talking about the description, that would be like the median income or the mean or the average or the mode or any of those values that you learned about previously in Algebra 1 or geometry. If it is a numerical description of a sample versus that population, that is what we're going to call a statistic. So in both cases, they are measures of the study. But if the original group, so it's all going to come down to that. If the original group is a population, it's going to be a parameter. If it's coming from a sample, that will be a statistic. So I remember P and P, S and S. So let's try this here. For the very first one, it says in example 1, for all households in Clay County in 2018, the median income was $68,367. Is this a parameter or a statistic? Well, let's look for some keywords here. If we look at that first sentence, we notice it says all households. Since all households were covered in this study, then this means that that numerical measure of 68,367 is going to be a parameter, since it is the median income for all households. If I compare that to example 2, it says a panorama survey was given at Liberty North High School, and the question was asked, during the past 30 days, how often do you come to class prepared? Of the 1,342 students that responded, 81% responded favorably, indicating frequently or almost all the time. Is this a parameter or a statistic? Well, since it says only of the 1,342 students that responded, that means that not all students responded. And so since it was not the entire student body, this is going to be a statistic. And that's because in this case, I'll write the word because, 81% describe the sample. Another way of saying that, not all students were surveyed. So now it's your turn. Pause the video here. I want you to do the next two on your own here. So it says, okay, if we go ahead and try this on our own, we should have got that the first one was a parameter. Again, since it was all the students that were surveyed, that keyword is all. And then on the second one, this was a statistic because that 50% is only describing the overall percentage of those that were going to be for those juniors that responded. So now we're going to go ahead and talk about the two different main areas of statistics, which is going to be descriptive and inferential. Our first one here is going to be a descriptive statistic. And if you think about the word descriptive, it means to, keyword there, describe. So descriptive statistics are going to be methods for organizing, displaying, and describing data by using tables, graphs, and summary measures. Examples of summary measures are going to be the mean, which we will also use as the Greek letter mu, so it's pronounced mu, which is the average of the data set, and also the standard deviation. Standard deviation uses the symbol sigma, which is also a Greek letter. So sigma, which is the average distance of values in a data set from that mean. And we'll talk more about that here in a sec. Our other type of statistics is going to be inferential. Inferential statistics are going to be methods that use sample results that help you make decisions or predictions about a population. So really descriptive is just to give us information. Inferential, we're actually going to do that inferring, meaning we're going to be able to use it to predict. So let's make sure we know how to distinguish between the two. So it says here, when a numerical description of a population or sample is given, such as a percentage, measure of center, or range, that is going to be those descriptive statistics. When we have a conclusion or prediction that is drawn about a population based on the information from a sample, then that will be our inferential. So let's actually put this into play. It says a panorama survey was given to the student population of Liberty Public Schools, including Liberty North High School. Look at the following survey questions with results. Determine if the descriptive or inferential statistics is being used and why. So notice, again, let's identify here, but that full population was all students in Liberty Public Schools. So that's our population. But our information is only coming from the sample. So any of these numbers are coming from the sample, meaning that they will be statistics, not parameters. Question 1 says, how confident are you that you can complete all the work that is assigned in your class? So that was given to all the students in the sample. A says 70% of the female surveyed at Liberty North student responded favorably. Since that is just stating a number, this is an example of descriptive statistics. And that is because it's just reporting a numerical description. Part B says males are less confident that they can complete all the work assigned to them in their classes than females at Liberty Public Schools. Well, if you look at the difference there, we can see that we have that broken down between the two, and males are on the right, females on the left. So based on the number, since 66% is less than 70%, we are inferring that males are less confident. Using that language, that means that we are inferring to make that prediction that the males are less confident. So this is going to be inferential, because we are drawing a conclusion about male students based on those statistics given to us. Let's go on down to question 2. says, when complicated ideas are presented in class, how confident are you that you can understand them? First one said, at Liberty North High School, 507, or 36% of respondents indicated that they are somewhat confident. Again, this is just stating a value, stating our statistic, so this is going to be descriptive. And that is because it's just reporting, once again, that numerical value. Part B says, at Liberty North High School, most students are confident that they can understand complicated ideas presented in class. So if I look at that table, it does seem that the higher percentage, if I look at those guys, the 41 and the 12, that is higher than those lower ones. So I'm saying, or just inferring, using to predict, that since most people responded in the quite or extremely confident, that most students feel that they are. So again, since I am inferring or drawing a conclusion, this is going to be inferential. Now I want you guys to pause the video and try this on your own. Okay, if we look here in question 3, it says, during the past 30 days, how much did you care about other people's feelings? Of the respondents from Liberty North, 79% of the females and 61% of males indicated they cared quite a bit or a tremendous amount. Again, since we are just reporting those numerical results, that is going to be descriptive statistics. Question 4, of the respondents from Liberty North High School, 31% of females and 41% of the males indicated it was quite possible or completely possible to change over time. Thus, we can make the conclusion that males at Liberty North are more likely to believe talent level changes over time more than females. So comparing those between the 31% and the 41%, we're drawing that the conclusion that males are more likely to believe than females, hence giving us inferential statistic here.